Hello everyone, my name is Sertac Arabacioglu from Mugla Kocman University. I would like to talk about the opportunities and challenges and innovation for 3D digital design. First of all, I would like to give a background knowledge about that presentation. Yes, the purpose of this study was to introduce new toolkits. It will make it easier for pre-service teachers to develop 3D digital designs from hands-on model. Generally, in my works, I focus on the distinct skills, not the all skills of the STEM education, or I focus generally on distinctive skills. So it's based on developing 3D digital designs of pre-service teachers. And I give you a background knowledge in NRC skills. We use the models in digital designs, using models to analyze existing system, using models to visualize a design and develop it further, to convey designers' characteristics to others, and to design performance as a prototypes. So these all four tasks are shaped our designs problems. And today's free online software tools offer various opportunities: 3D design, 3D modeling, and 3D digital prototype development. However, many teachers do not transfer such opportunities to student design process. You can see here a landscape of WOS viewer, and these data come from March 12th from the Web of Science database. Approximately 117 articles related to 3D printing, 3D digital design, and 3D with the keyboards. And you can see here the design in the middle of the working areas. So I can show you a bridge. The bridge between science, education, and the 3D printing. The design is an important point in this process. So I offer for 3D designers and 3D printing, doing the 3D printing, they focus design process. And the design process plays significant mediating role in this kind of work. In this paper, I will explain all these kinds of opportunities and also the working areas in full text of this paper. But here I just show the main idea of this presentation. You can see here some photographs. These are my students' works. 3D digital design of built turbine blades. These are just only elementary science pre-service teachers, and they design this kind of works in their courses. And I give this course in approximately for 2 years, 3 years, current application in educational technology in our faculty. Yes, I introduce in this paper toolkits. But first of all, I give a background knowledge about my previous experiences. I am a photographer, approximately 11 years. And when I pass lots of, how can I say, area. And from the drawing to manipulating negative films to Photoshop to today's virtual designs and augmented reality and also the other things. So I just think that these kind of skills, how can easily pass that kind of the areas. So I designed that kind of toolkits based on my previous experiences. So I just firstly focus on analyzing the problem or the goal. This is the first toolkit of my courses. and identify the goal of making the 3D digital design. What's their purpose? Using model to analyze existing system, or visualize a design, or to test the performance as a prototypes. You can see here some designs. For example, the final one is just to test the design performance as a prototypes. They print them, they test them with real performance. The first one just focus on the visualize model. And you can see the second section. Understand via task, via hands-on model, not the think that we started from real model. And the final digital design had also a wide variety of structural elements. They show the model, like artists. They design a tool or a artifact. They print them with 3D printers, and also they put in the digital platform. This is the basic topic. And the second one in this toolkit, identify the constraints and requirements of the design. Some of the design have one-to-one dimension with a single beam construction. The others show the entire model while ignoring some technical issues. And we focus in the second toolkit, transiting from hands-on to real object into a two-dimensional drawing, not directly the 3D digital drawing. Just we pass through a bridge, pass through the two-dimensional drawings, and identify the constraints and requirements of the design, the basic skills and experience for measuring. Just measure it. And you can see here some photographs of my students. The first one is comes from my woman student. She draws the model like an engineer, like a. It's really interesting, but this is not a chance, or this is not a skill. First of all, we teach them how to technical or non-technical drawing doing that. So I show them StudyCAD CAM technical drawings and how to measure it and how to do that. And also, we give a background knowledge of 3D modeling software, Tinkercad. How to use this kind of Tinkercad, how to use the plane of the Tinkercad, how to use the measure, how to use to think 3D. And the third one, the third toolkit, converting two-dimensional sketches to 3D-dimensional digital design. The competence to utilize units or real units, transformations, angles, and geometric shapes, as well as the ability to operate a software quickly and effectively. This is really interesting. Most of the students have a problem with measuring. When they draw something, if we print that's too much big, or sometimes that's too small, because the digital in the digital platform different from our vision in the real time. So we first of all give them the units, how the units transform in the real platform to the digital platforms. So you can see here final products, our results. You can see their success also. If they measure and if they successfully pass through all the how can I say, toolkits successfully, they design very well production 3D digital designs. Finally, you can see some products. You can see the second one. If they have a problem with measuring and drawing, the final product has some problems. Limitations, I would like to talk about limitations of the study include that the design tasks are considered on wind turbine blade design and the usage of the Tinkercad online software tool in 3D digital designs. The direction for the future studies, despite these limitations, the findings have theoretical and practical implication for how teachers might assist students in completing digital projects. Closing statement, the present research therefore contributes a growing body of evidence suggesting the toolkits for teacher education programs and professional development in engineering design practices in teacher education. And thank you very much. My presentation.